Right, so last thing we're going to look at this week is trig identities. We're basically going to split this one section into 3 parts. Okay, we'll do part 1 today, part 2 tomorrow, and then Monday just kind of a review of parts 1 and 2. So what I'm going to start out with is just a little bit of background over kind of what an identity is. I'll even show you an identity just from like algebra, and then we'll look at identities in trig. Okay. If I can show you on an algebra first, you'll probably understand that better because it's simpler than when we do it with trig. All right, so suppose we had 2 different functions. Okay, you can name them anything you want, f of x, g of x. I'm using f and g. In order for these 2 functions to be identically equal, basically in order for them to be the same, what that means is every single value you plug in to the first function, you're going to get a number. If you plug that same value into the second function, it would come out the same for every single number you can think of. So if you plug 2 into function f, you're going to get an answer. If you plug 2 into function g, you're going to get an answer. Those answers have to be the same. Okay, for every single number you could ever plug in. If that's true, then the 2 functions you have are equal. They're exactly the same thing. So here's an example of 2 functions that are not equal. F of x equals 3x. G of x equals 4x. They might be equal some of the time. Like if you plug in 0 for x in the top one, what do you get? 0. What if you plug in 0 for x in the bottom one? You get 0 again. So you say, oh, they're the same. Well, they're the same for that specific number, but now if you plug in, say, 2 for x, in the top one you get 6, in the bottom one you get 8. So no, it didn't work for all numbers. Okay, it worked for the number 0, but it has to work for any number you can plug in. You got to get the same answer in both spots. So those are not equal, except at the number 0. That's the only time they are. Okay. So that's an example of an identity from algebra. Function f of x and g of x are exactly the same thing. Now, somebody that doesn't understand algebra, like maybe someone in 2nd or 3rd grade, would look at that and say, no, they don't look the same. This one has 2's in it, this one doesn't have 2's, but they are the same thing. What property could you use in the bottom one to make it look like the top one? Distributive. Yeah, distributive. If you distribute it out, you get 4x plus 8. Right? So with a little bit of work, f of x and g of x are the same thing. Okay? Those 2 functions are identically equal. Same thing. Any questions on that? Okay. So, next thing we're going to look at is what's called an identity. So an identity is an equation that is true no matter what number you pick to plug in. So, take something like, let's just take the example above. So say I take that to the next step and I put on like a test, a question like this. I say solve 4x plus 8 equals 2 times 2x plus 4. Well, if somebody started to solve that in Algebra 1, if they did it correctly, the first thing they would do is distribute on each side. And then they would realize, wait, 4x plus 8 equals 4x plus 8. You get something like this. And maybe for some reason, if they didn't notice it was the same on both sides, they might say, okay, I got to put all the x's on the same side. So now I'm going to minus 4x from each side. Minus 4x, minus 4x. But now at this point, you should kind of realize, wait a minute, x's are gone, x's are gone. I'm left with a true statement. Okay? When you solve an equation and all the letters disappear, and you get a true statement, like 8 equals 8 or 12 equals 12, something like that, that's called an identity. Okay? That means if you were to try to solve this original problem, the answer for x is anything you want. You could plug in 2 and it would work. Plug in 5 and it would work. You could plug in anything. Because what's on the left and what's on the right is the same thing. All right? So that's what we're going to look at, except it's going to be trig. Okay, I'm going to give you guys some equations. What's on the left is going to be the same as what's on the right. Okay, so it's not going to be algebraic. It's going to be trig. So there's 3 main groups of identities we're going to look at. Okay, in general, I mean, there's hundreds of these identities. Okay? Eventually, they start to get complicated enough that you really don't memorize them. If you need them, what you usually do is you look it up, like using a calculus book, in the front cover or the back cover, they're all there. You can just look at the front cover and they're all listed. So if you need to use one, you look it up. Okay. We're never going to go to the next step with identities problems, which is usually to do something in calculus. All right? So we're not going to get to that next step. Right? But if you have to take calculus, you'll take this one step further. So these identities I've already given you guys, right? We don't have a cosecant, a secant, or a cotangent button on the calculator. So the only way that you can type in any of these 3 is to take the sine and flip it, take the cosine and flip it, take the tangent and flip it. And the reason it's an identity is because that's true all the time. It's not like this formula only works if your angle is 10 degrees. No, this formula works if your angle is 12 degrees, 78.3, doesn't matter. You can always flip the sine and you will always get the cosecant. All of the time. Always true. That makes it an identity. Now, I'm going to write 3 other ones. Okay. But they're really going to be the same thing. Okay. Let me show you for a second what I mean. Have people heard of that formula before? Distance equals rate times time? Okay. Is this a different formula? No. That's the same formula. It's just written a different way. Same thing if I said this. Okay. If you think that that's 3 different formulas, it's not. It's just taking the same formula and writing it different ways. Well, specifically, let's look at a pattern in those 2. When you have a fraction like that, you can always switch these 2 things and get another version of the same formula. And that's exactly what happened right here. Switch the t and the r, and you get the formula that's down below. Well, we can do the same thing right here. You can switch those 2 and get a different version of the same formula. Okay? So we could say that sine equals 1 over cosecant. And that is not a different formula. That's the same as the first one. It's just moved around a little bit. Okay, so doing that same idea, anyone think they could tell me how we could rewrite the second one?
Cosine equals SEC one, whatever it's called, 1 over that.
1 over secant.
Secant.
Yes. So so far, all we're really saying is if you take the sine and flip it, you get the cosecant. If you take the cosecant and flip it, you get the sine. That's all. How about this last one? What could I write for that one?
Tangent equals 1 over cotangent.
Yeah. Tangent equals 1 over cotangent. Okay, so those are all reciprocal identities, technically 3 repeats in there though. Okay, the quotient identities, there's 2 of these. Did anyone remember, and I showed you guys this at the end of class yesterday, tangent is equal to something over something. Anyone remember what we came up with at the end? Yeah?
Tangent equals cosine over sine.
Sine over cosine, yeah. Tangent is sine over cosine. And we figured that one out by kind of looking at the unit circle trig, and we said, oh, okay, tangent is y divided by x, but y is sine, and x is cosine. So tangent is sine over cosine. Now, what's the connection between tangent and cotangent, if you look back up here? Oh, Courtney?
You lost me.
What's the connection between tangent and cotangent?
They're
They're the reciprocal. You flip one to get the other. So, based on that, we can write cotangent, I mean, we can do it the way I did up above, but I can also write it another way.
cosine over sine.
Cosine over sine. Cotangent and tangent are just the reciprocals of each other. And tangent is this, then cotangent must be that one flipped. Now, there's one more group of identities, but I'm not going to give you those today. There's, in that last group, there's 3. So the first group, there were 6 with 3 repeats. And then the quotient, there's 2. And then we have 3 more. The last group are called Pythagorean identities. I showed you guys one yesterday, but it has to do with powers of 2. But I'm going to show you those tomorrow. All right. So all those identities that we just wrote, technically they're all to the first power. We didn't write that. Okay? But if we go back up, this means cosecant to the first power, sine to the first power. Okay? When you put a power on a trig function, that's where you put it. Okay? So if you see something like this, it means this. Same. Right? Just for whatever reason, they usually put the exponent right on the trig function itself, but those are the same thing. Right? So all of these identities basically have exponents of 1, just like any number. If you don't put the power, it's always a 1. Okay? Well, all of these identities work with higher powers. So if tangent is sine over cosine, then tangent squared is sine squared over cosine squared. Tangent cubed would be sine cubed over cosine cubed. I mean, I could write down a bunch of them. And same thing with the reciprocal identities. If you flip the sign, you get the cosecant. If you flip the sine squared, you get the cosecant squared. What if you flip the sine cubed? What do you think that would give you? Oh, that's
Cosecant.
yeah. If you flip sine to the 4th, you get cosecant to the 4th. Generally, we don't go much higher than 2, but yeah, it's perfect. That's exactly what happens. Okay. If you get into a problem and the exponents start getting higher than 2, then something's probably wrong. You probably want to go back and double check something. Are there trig identities where the powers get higher than 2? Oh yeah, definitely. But we don't really look at those. All right. So basically, the goal with trig identities is to take something that looks kind of complicated or has multiple functions in it, like that one has 2, and try to simplify it as much as you can. So there's a few different tricks we can use to simplify trig expressions. And this trick is kind of it's pretty universal. You can almost do this every time. You can take everything in your problem and rewrite it as sine and cosine. There's always a way to do that with the formulas I just gave you. Right, so let's kind of go through it and look at this first one. So it says secant times cosine. And notice there's no number there because the number doesn't matter. We're going to simplify the expression secant times cosine for any number you would ever want to plug into it. It doesn't matter what number. All right. So let's start with secant. That's not sine and cosine, but I can change it so it is. So using the identities I just gave you, can somebody tell me a different way to write secant? One over cosine. Let's go back and look at our identities. Secant equals 1 over cosine. So basically what you're doing with trig identities is a lot of substitution. You're changing something out. Right? So change out secant for 1 over cosine. All right, so we'll start with that. So secant times cosine. So that's the first part, 1 over cosine. And now, Alyssa, is the second part already a sine or a cosine? Yeah, so we're just going to leave it. We're not going to change that. But since I have a fraction on the left, let's make this a fraction on the right. Andrew, how can I make cosine a fraction?
Cosine theta over 1.
Yeah, we just put it over 1. And now we're going to multiply those two fractions together. Max, what's going to happen there when I multiply these two fractions together? Max? Hey. What's going to happen when I multiply these two fractions together? So what if you had like 1 over 4 times 4 over 1? That's basically what you've got right there.
And you have to flip the 4 over 1.
Sometimes you have to flip, but that's only if you're dividing a fraction by a fraction. This one, you just multiplying. No, you're thinking of like a proportion. If you had something like this, that's when you do 2x equals 15. You cross multiply. So no equals sign here. Brianna, can you help them out? What's going to happen there?
We cancel out.
Yeah, what would cancel in this 1 over 4 times 4 over 1? The 4s, right? 4 goes into 4 once, 4 goes into 4 once. Exactly the same thing happens here. You have a cosine in the top, cosine in the bottom, right? Top and bottom cancels out. Sebastian, if I do that, what's left in the top now?
1.
What's left in the bottom?
1.
What's 1 divided by 1?
1.
1. And that's your answer. So this is a trig identity that when you simplify the whole thing down, all the trig actually is gone. And the answer is just a number. That usually doesn't happen. Okay, but in this one, it did. So that means if you told me to multiply the secant of any angle you could ever think of times the cosine of that angle, the answer would always be 1. Secant of 12 times cosine of 12, 1. And the answer is always 1. And now, if we had to do something else with that, it's a lot easier to work with the number 1 than it is to work with two trig functions multiplied together. Okay? And these are exactly the same thing. That's just simplified. Okay. So that's the idea of what we're doing. Any questions on that? Okay, pretty much every rule that you know about arithmetic still works with trig functions, right? Like if you had x plus x, that's 2x. Sine plus sine, 2 sine. Same thing. Distributive property can also do that. Okay, everything you know still works. Okay, let's try this one. It's 1b. Okay, so they want us to simplify cotangent divided by cosecant. All right, so Matt, what's the trick that I taught you to do, and we did this in the last one.
What do you mean?
Like there's a trick to start this problem off. I said one trick is to change everything to
Sines and cosines.
change everything to sines and cosines. Okay. Don't even worry about what's going to happen next. Just do it. Hope that eventually something cancels out. So we'll start with cotangent. Anthony, how can I rewrite cotangent? I got two ways to do it, but I want to do it with sines and cosines.
Would it be 1 over tangent?
But that's not with sines and cosines. That is correct, but in this problem, that one won't help you. But that might help you in another problem, just not this one. It's under the second group, where there's two of them, two identities.
Oh, cosine over sine?
So yeah, let's make the top cosine over sine. Okay, you might be looking at that and saying, well, now we just made it worse. We only had one thing in the top, now we have two. It's going to get worse before it gets better. Kind of how things usually go. So, cosine over sine. And now cosecant. How can I rewrite cosecant? Yep.
1 over sine.
1 over sine. Now, what I have there is what Max mentioned before. We've got a fraction divided by a fraction. And Max, what did you say to do when you have a fraction divided by a fraction?
I don't remember.
Hey, you want to remind Max what he said? Yeah.
Reciprocate.
Okay, can you tell me, what do I write?
I don't know. I just said reciprocate.
So we do want to do something with reciprocal, but I need more info. I need more direction. Multiply by the reciprocal. What about the top? What do you do with that? Like what if you had this? 2/3 divided by 4/5. What would that turn into?
3/5 divided by 4.
Not quite. You flipped something, but you flipped the wrong thing.
You multiply by 5/4,
Multiply what by 5/4?
the top and bottom, something like that.
Let's just start with multiply by 5/4.
Just the 2/3?
So 2/3.
Oh, okay.
Okay. So we're good with multiplying fractions, right? No? Okay. Keep the top the same. Keep change flip, right? So they teach you, maybe? I don't know what they teach you now. But keep the top the same, change the division to multiplication, and flip the bottom. So you multiply the top by the bottom flipped. So now we'll do the same thing here. Keep the top the same. And multiply by the bottom flipped. Okay. Now what's going to happen when I multiply those two fractions together?
Sine's getting cancelled out.
The signs cancel out. You can always cancel trig functions if you have the same thing in the top and the bottom, and it is multiplication. If it's addition, no. If it's subtraction, no. You can never cancel across an addition or subtraction sign. Okay, only multiplication. So now, Grace, what's left in the top?
Cosine.
And what's left in the bottom?
1.
1, so it's just cosine. And that's your final answer. So if you had to take the cotangent of a number and divide by the cosecant of the number, it's a lot simpler and equal to just take the cosine. It's exactly the same thing. A lot quicker, it's one trig function instead of two, and there's nothing you have to divide. And that's it. Any question on that one? So what I usually do is when I get confused with this, I kind of fall back to what I would do with numbers, right? So if you're a little confused, like we're going to get into things like this eventually. So like you need to know how to add fractions. So maybe we'll just talk about that real quick. Why can't I add those? I don't have the same denominator. How do you, what is the common denominator there? 15. How did you get it? That's the important step. To get the denominator the same, just multiply the two denominators you have together. So you'd have to multiply top and bottom of this fraction by the other denominator, and top and bottom of this fraction by the other denominator. Now you'd have 10 over 15 plus 9 over 15, and now you can add them up. Okay, but that's what I'm trying to show you. Multiply one fraction by the other denominator, and this fraction by the other denominator, 3. Right? Because we're going to do the same thing, except it's going to be trig in a little bit. But it's the same rule. Okay, cosecant times tangent. Okay, as far as difficulty, this is about the same difficulty as the last two. They get harder, but not crazy hard. I mean, some identities, could be 15, 20 steps long. So far, we've done ones that are about 2 steps. We will never be doing one that's 15 or 20 steps long. All right. So, Emily, what's the first thing that we've tried so far in the last two?
So change it to cosine and sine.
Change it to cosine and sine. I'm not going to say that that's going to work 100% of the time, right? But most of the time it will work. Okay, start with cosecant. Gabe, what's cosecant? 1 over sine. Now, it doesn't matter what that is at all. I mean, I could have cosecant theta, cosecant x, cosecant y. It's just a variable. Okay, so this can be anything you want. That's not really important. Just whatever they use in the problem, you use the same thing. Okay. So 1 over sine times, how can I rewrite tangent? We've got 2 ways. One of them is more helpful than the other here. Yep.
Sine over cosine.
Sine over cosine. If you change everything to sines and cosines correctly, every problem I give you is set up so that something nice will happen. Okay. If you don't notice something nice happening after the first couple steps, something's wrong. Okay, you made a mistake. All right. So now, when I multiply these together, Stephen, what's going to happen there?
What do you need, flip it?
Nope, no flipping there, because we're not dividing fractions.
Oh, so the signs are going to cancel out?
The signs are going to cancel out. What are you left with?
1 over cosine.
Yep, 1 over cosine. And sometimes these are a little tricky because it's like, okay, well, where do you stop? Is that done? Well, I would say if you can write something not as a fraction, that's simpler than having a fraction. So we can simplify 1 over cosine. What is 1 over cosine?
Secant.
It is secant. Yes. Is there a big difference between those last two? Not really. I mean, either one of these could be correct. But personally, I think without the fraction is simpler than with a fraction. Any question on that one? So what that basically means, if you take the cosecant of anything you can think of times the tangent of that, it'll always be the same as just doing the secant. Okay. All right. Let's look at this one. All right, so changing everything here to sines and cosines isn't really going to help, because it already is. The only thing that aren't sines and cosines are the numbers 1. What are you going to change 1 to? It's already a 1. So, the second trick, and we've used this trick before, is to multiply by the conjugate. Last time we saw this trick is when we had problems like this. We had to divide by a complex number. We multiplied top and bottom by the conjugate. The conjugate in that red problem is 4 minus I. The conjugate in this black problem is 1 plus cosine. It's just when you change the sign of what's in the middle. Now, this is where identities can get a little tricky. Because when you're doing an identity, it's kind of like, the way I describe it is like playing chess. Does anybody play chess? All right. So,
Dude, I'm nice with chess.
when you play chess,
Dude, I'm crazy nice with chess.
what are you thinking about when you're making a move?
What am I gonna do next?
You're thinking ahead, right? You're always thinking about, okay, if I do this, maybe they're going to do that.
Chess app on my phone.
Okay, and then if they do that, I'm going to do this. So you're trying to think ahead 2 or 3 moves. That's not easy. Okay, anyone that plays that game a lot, I don't play it, but if you play it, that's hard to do. It's very, very hard to predict what's going to happen. Partially because you're playing against a human, they can do anything. Well, we're playing here against math. Math can't do anything. Math has to follow very strict rules, and it has to do exactly the same thing every single time you do it. So it's predictable. But you're trying to think ahead about what's going to happen. So I'm going to show you how I would think about this problem, and you'll see as we go through it. So I'm going to just copy it down first. 1 minus cosine squared over 1 minus cosine. So I said here, try multiplying the top and bottom by the conjugate. Again, don't worry about sines and cosines because you can't. So you got to try something else. So anytime you multiply by conjugates, parentheses are always a good idea, so you remember that it's distributive. And what's the conjugate of what's in the bottom? 1 plus cosine. So we're going to do that here. And we're going to do that here. Now, this is FOIL. You have to distribute it just like you would distribute something like this. First, outer, inner, last. But I'm only going to distribute what's in the bottom. I'm not going to do the top. And this is because I already know what's going to happen in the next step. How do I know that? It's just, I don't know. How do you know how to play chess? You just practice it and you get better at it. Or you get frustrated and quit. But try not to. So let's leave the top. Leave the top exactly the same. Okay, don't do anything with the top. Another reason I don't want to do anything with the top is because I'm looking at this, and if I FOIL it, the first is okay, the outer is okay, the inner is okay, but I don't like the last. Like, cosine squared times cosine is cosine cubed. I told you we weren't going to get into identities that had exponents of 3. All right. So if you were going to do a step out, and all of a sudden you think that step is going to give you an exponent higher than a 2, don't do that step out yet. Hope that if you do out the bottom, it magically cancels something in the top, and you never have to worry about doing it out anyway. Okay. So just leave the top the same. 1 minus cosine squared times 1 plus cosine. And you'll see that in a minute, something in the top isn't even going to matter. It's just going to go away. Now, let's do out the bottom. Okay, so we'll FOIL it. What's 1 times 1? 1. How about 1 times cosine? Cosine. 1 times negative cosine? Negative cosine.
I am, dude.
And now, the last part, what's a negative times a positive? Start with that.
Negative.
It's a negative. Cosine times cosine. It's just like doing x times x.
Cosine.
It's cosine squared. X times x is x squared. Cosine times cosine is cosine squared. Now, what cancels out in the bottom? Positive cosine, negative cosine. What's left in the bottom now? In the bottom is 1. I'm not going to rewrite the whole thing. It's 1 minus cosine squared. But where else is 1 minus cosine squared? In the top. So then the whole thing cancels out. It's kind of like having 3 times 4 divided by 3. If you've got the same thing in the top and in the bottom, they cancel out. And all you're left with is what was in the top. That's exactly what happened right here. 1 minus cosine squared in the top. 1 minus cosine squared in the bottom after you simplify. So the only thing that's left, 1 plus cosine. And that's your final answer. So it doesn't look a lot more simplified, but look at what we started with. We had a fraction. We had 2 trig functions. The top one was raised to the second power. The bottom one was just to the first. And now we ended up with just a single trig function with a plus 1. That is a little bit simpler than what we started with. But you can't simplify it any more than that. That's it. Okay. Any question on that? Okay, so the nice thing, at least about the identities I'm going to give you, is you're never going to see one that doesn't follow the pattern of one that I've already done. It's again, oh yeah, he did a conjugate one, maybe this is the conjugate one. Or he's changed to sines and cosines, this looks like a sine and cosine. You're never going to have one where you have to figure out some brand new method to solve it that I've never showed you. Right? Most identities, that's how they really are. Right? You just get something really complicated and you just got to try everything you know to make it work. Right? But you guys are only going to have like 3 different things to try. Okay, and I've shown you 2. Okay, let's look at this one. So, that one looks like the most complicated one we've done so far. Secant times 1 minus sine squared divided by 1 plus sine. Now, if you had to pick between changing to sines and cosines or multiplying by the conjugate, which one would you pick here? Because one way is going to make the problem pretty easy. One way is going to make it pretty hard. Which way would we choose?
Find sine and cosine.
We've just entered Awfulville. But that's okay. You don't know. To me, when I look at that one, look at those 2. You have the 1 minus sine squared, 1 plus sine. 1 minus cosine squared, 1 minus cosine. This pattern is kind of like this pattern here. But how would you know that? You don't really know that. It's the first time you're trying it. You could try it. And if you change to sines and cosines, it will work eventually. But it may take you 15 steps versus what we're going to do may only take like 3 or 4. Right? So what I would do on this one is multiply by the conjugate. Only because I see this squared thing and then I see the same thing down here not squared. Usually the conjugate can make the squared thing go away. And then you don't have to worry about it. Okay. All right. So what's the conjugate there? One minus sine. So I'm going to multiply the top by 1 minus sine and the bottom. Do you think I want to do out the top? No, top looks awful. If you were to multiply all this together, you'd have to FOIL these two together. And look what would happen when you FOIL the last. You'd have a sine squared times a sine, which would be what? Oh, Alex, what would sine squared times sine be?
Sine cubed.
Be sine cubed. Remember I told you we want to stay away from things that get cubed, right? So don't do that out now. Just skip it. Do the bottom and hope that the top just goes away, right? Just hope something will cancel out. Okay, so if you see something that would give you something like a cubed, don't do it. Just hold off on it for now and do something else in the problem, and it will probably go away. So the top, we're going to keep exactly the same. Secant, 1 minus sine squared, 1 minus sine. Now let's do the bottom. Okay, so FOIL out the 2 in the bottom. What's 1 times 1? 1. 1 times negative sine?
Negative sign.
1 times positive sine?
Sign.
So those are going to cancel. Right, so I'm not even going to write it. Negative sine, positive sine. That's 0. Now do the last part. A positive times a negative is a negative. What's sine times sine? Sine squared. Okay, now what happens?
The sine squared on the top cancels out the sine squared.
What's going to cancel out?
The 1 minus sine squared on the top.
Right, the whole thing in parentheses. Okay, this whole thing and that whole thing is gone. Now you don't have to worry about a sine cubed or anything like that. It just disappeared. Okay. I will always set the problem up for that to happen. You just have to get to this step to realize that it happened. Okay, so now we've got secant times 1 minus sine. Okay, what property could I try there? I don't know if it's going to get any simpler. I'm not sure. I haven't done this problem in a year. So maybe it gets simpler, maybe it doesn't. I'd have to try and see. But when you have parentheses and you have something on the outside, what property can you use? Distributive. Let's try the distributive property and see if anything simplifies. Okay, I don't know if it will. Maybe it will, maybe it won't. Secant times 1 is just secant. Secant times negative sine, there's nothing I can do. That's just secant times negative sine. That's what you get when you distribute it. Secant times 1 and secant times sine. Sometimes you start doing an identity and you just go down this hole of nothing and end up nowhere. So let's see. Let's try changing secant to sine and cosine and see if something good happens. What is secant the same as? 1 over
Cosine.
1 over cosine, yeah. So let's try it. 1 over cosine minus 1 over cosine times sine. Well, let's put that together. What's 1 over cosine times sine? Sine over cosine. That's sine over cosine. Now, what is sine divided by cosine? That is something special. That's tangent. That's tangent. And now, this first part, we changed it to 1 over cosine. I don't really like that we did that because it made it a fraction, and I have nothing to combine it with. So I actually think it was better the way it was before. Secant. And now, I mean, we're done with that. Okay, there's really nothing else we can do. If you try to go further than this, you're just playing games, rewriting the trig function, but you're probably not going to get it any simpler than that, right? So some people may stop at this step and say that that's, you know, pretty simplified. I'm seeing 3 trig functions there. 2 of them are the same. Well, now I only have 2. If I can go from 3 down to 2, that is simpler. Okay, and that one was kind of on the upper end of medium. That one was getting towards a harder one because there was a lot of steps in it. Any questions on any of the steps we did? They had a lot. We had a conjugate, something canceled, distributive property, change to sines and cosines, and then use an identity to change that to tangent. So that's probably the hardest one we've done so far. Let me see. 2 left. Okay. Let's look at this one. Now, this is one that if you see it right away, you can do it in one step, the whole thing. If you don't, you may end up doing 8, 9, 10 steps, and then you're just going into this spiral of paranoia and craziness. And at that point, you just want to stop and say, okay, you know what? I'm going to back out. I'm going to try something else. And I'm going to make this look very easy by the questions I ask you, but if you don't see this right away, then it could be tough. Before I say anything, does anyone see anything right away?
Got sine x over cosine x, which
Okay.
is basically tangent.
It is tangent, yeah. So that's tangent. What about 1 divided by cotangent? So it's what?
It's reciprocal there.
1 divided by cotangent. This is the reciprocal of tangent.
Oh, it equals.
That equals tangent.
Yeah, I see.
1 divided by cotangent is tangent. And look what just happened. You have a tangent plus a tangent. So how many of them do you have? 2. Done. You have a tangent plus another tangent, so you have 2 of them. If you said, okay, well, I'm going to change cotangent to sine over cosine, or cosine over sine, then you're going to have fractions over fractions. You're going to multiply by the reciprocal. You'll get here eventually, but it's going to take a lot longer. But that's the trick on that one. So, does anyone want me to change this to sines and cosines and show you how you get to the same spot eventually? No? Any question on how we got to tangent? Okay. The arithmetic or the math you're doing here, that's not hard. Tangent plus tangent is 2 tangent. That's easy. It's, did you notice to change that to tangent and change that to tangent? That's the part that's hard. Did you notice that? Okay, so I think this is, oh, it's the last one. So one trick we've done is we've changed everything to sines and cosines. What's the second trick I taught you? Not an identity, but like there's going to be 3 of these tricks. The first one was change to sines and cosines. What's the second way we've started off a problem?
Using the conjugate.
Using the conjugate. Well, here's going to be the third way. And I showed you guys kind of a little preview of this with numbers earlier. You've got 2 fractions. Do they have the same denominator?
No.
No. So let's make them have the same denominator. Usually, if you write something with a common denominator, if the person who made the problem is nice, something good will happen. By good, I mean it's going to cancel out. Right? At this point, don't even worry about what's going to cancel out, because now you're trying to think 4 steps ahead. Just do 1 step at a time. Find a common denominator, and then go from there. So we had a problem like this. I don't know if that's the exact problem I did, but how did we find a common denominator?
We multiply it.
Cross multiply.
That's when you have a proportion.
We multiply the left fraction by the right denominator.
Yeah.
The right fraction by the left.
You multiply each fraction by the other denominator. So here, multiply by 5 over 5, and here, 3 over 3. Then you'd get 10 over 15 plus 12 over 15. We're going to do exactly the same thing in our problem. You know what? I'm going to do it in the first step just so I don't have to copy the whole thing again. Multiply each fraction by the other denominator. Cosine over cosine. Now there's two things there. Anytime you got two things, put parentheses around it, because that's distributive. And what am I going to multiply the other fraction by?
Sine theta.
Yep, over.
Over 1. Oh wait, over sine theta.
Over sine theta. You got to multiply the top and bottom always by the same thing. So what's my common denominator now?
Cosine theta times sine theta.
Cosine theta times sine theta. Or sine theta times cosine theta. It doesn't matter. You can write it either way. Cosine theta, sine theta. There's your common denominator. Now, in the tops of each denominator, that's a distributive property. What's cosine times 1?
Cosine.
Cosine? What about cosine times sine?
Cosine times sine.
There's nothing you can do with that. Just cosine times. It's like saying what's x times y. It's just x times y. So cosine, let's put that down first, plus cosine times sine. Now, we have to do distributive property in the second part. That's sine times cotangent. Again, that's like x times y. You can't do anything with it. Maybe we can change cotangent to sines and cosines later, but let's think about that later. Okay, let's finish common denominator first, then we can try that after. So we have sine times cotangent. Sine times cotangent. And now this is the part I want you to look at. You have a negative cosine times a positive sine. That's just a negative cosine times sine. Negative cosine sine. Now something there better cancel out, or it's going to be a mess. Does anybody see what cancels out? Yep.
Positive cosine times sine and negative cosine times sine.
Positive cosine times sine, negative cosine times sine. 4 things just disappeared completely. Okay, now so we can see it, let's write down, let's write what we have left now. Cosine plus sine. Oops, over cosine sine. All right, so here we wouldn't want to do common denominator. We've already done that. Common denominator is when you have 2 separate fractions. We don't have that. We have 1 fraction. How about conjugate of the bottom? Do we have something plus something in the bottom? No. Do we have something minus something in the bottom?
Wait,
You have to do multiplication.
We have multiplication in the bottom, right? Conjugate only applies when you've got something like that, like a 1 plus sine, or where's the example? 1 minus cosine. 1 plus sine. You don't have a number plus anything. Like Matt said, it's multiplication in the bottom. So conjugate's not going to do anything here. What's the last trick that we have? and we'll see if it does anything. Change everything to sines and cosines, and there's only one thing we have to change. So you could just cross something out in that step and rewrite it above it. I'm just going to rewrite the whole step. Cosine plus sine times, I'll come back to that, cosine over sine. So I copied everything down that was sine and cosine. What is cotangent? It is 1 over tangent, but we're going to change everything to sines and cosines. So it is cosine over sine. Now, just to have it, anytime I multiply two things together, if one of them is a fraction, I just make the other one a fraction too. Now, focus on that part right there. What happens in the part that I circled? The signs cancel out. You have a sign in the top, sign in the bottom. What's left in the circle part? Cosine. Just cosine. Cosine plus cosine. How much is cosine plus cosine? 2 cosine. 2 times cosine over cosine times sine. Okay, whenever I get confused, if I look at it and I'm not sure, pretend like it was numbers. 2 times 5 divided by 5 times 3. Okay, I just plugged in a 5 for cosine and a 3 for sine to look at it with numbers. What would happen there? You were going to divide those fractions. What would you do first? Cross out the 5s. 5 in the top, 5 in the bottom. So the answer is 2/3. So what's going to happen in this one? Cosine in the top, cosine in the bottom. Cancels out exactly the same way the 5s did. What's left in the top? 2. What's left in the bottom? Sine. So look at what we ended up with compared to what we started with. We had a problem that had 1, 2, 3, 4, 5 different trig expressions, 2 separate fractions, some addition and subtraction in each numerator, and we simplified that whole thing down to 2 over sine, just one trig function. Right, so again, that one probably, I don't know if it's the hardest or second hardest one we did today. But that's about as hard as they get for what we're doing. Okay. Any question on that one? So I've done maybe 6 or 7 of these. Okay. And probably when you see me do them, when I write it out, then you look at it after, you're like, oh, it canceled. Okay, I see it. Something in the top, something in the bottom, it's gone. When you start to do it on your own, you'll probably get stuck, right? Because if you make one mistake, and for some reason, like maybe you had tangent here instead of cosine, then you're all messed up because now nothing cancels out, and you're like, where do I go from here? So if you get frustrated with one, my advice would be just skip it and try another one, right? Because you might have better luck with that one and then come back to that other one later, right? Just staring at the same problem with these things for 15 minutes is not going to help. It's not going to help. If you're stuck, you're probably stuck, right? So we'll go over more of these tomorrow. I think there's like 12 or 13 problems on the worksheet. So we'll go over them, and I'll make sure I put a copy of the worksheet in the video in case you lose it. Okay, so first problem on the homework. It says secant times cotangent equals cosecant. What I'm doing here is I'm telling you the answer. On the right-hand side, that's the answer. So when you're done simplifying the left, you should get what's on the right. Don't ever touch what's on the right, just leave it alone. Okay? This is how you do the left. Secant is 1 over cosine. Cotangent is cosine over sine. What cancels out there? The cosines. You're left with a 1 in the top, you're left with a sine in the bottom. If you take sine and flip it, what trig function is that? That's the cosecant. So that's the answer you got when you did your work. I told you the answer you were supposed to get, so that way you know when to stop. Okay? When you're simplifying the left-hand side, when it looks the same as the right, you're done. So you don't have to guess where to stop. Okay? That's how they're all set up. Okay? So don't ever touch the right-hand side. That's just your goal. Play with the left-hand side till you get it to the right. And that's number 1 on the homework.